independent, independent, anything on the right is the y or the dependent variable, okay? And that kind of helps you understand this. So in this case, time is affecting the temperature, okay? Okay, so then we just plot points like a regular normal cast. So 0, 25, 0, 25, make a point, 10. Okay. Now if you notice, this line isn't a completely straight line. Like you can't really draw a line, a straight line that covers all of that. So we're going to draw a line of best fit. Okay, so a line of best fit that we're going to draw. Now this one, I gave it a shot and it didn't work too well. So line of best fit, we'll draw, kind of find the best, so something, not like this one, something like that. That's totally okay if you use a line. It doesn't have to be completely straight, but you want to use at least a straight edge to get the best line possible. Okay, so now I draw my line of best fit. Alright, now let's go ahead and label these axes. Now, the axes that we have, now turn off my pen, the axes that we have here are, we need to label them correctly. So this is our x-axis, this is our y-axis. Now remember, we're going to label them based off of our independent and dependent variable. So our independent variable in this case is time, so we'll label this time. Now the units we put in parentheses, so our units are minutes, and then the same thing with temperature. So temperature is here, and then that is in degrees Celsius. Okay, so there we have time and temperature. We labeled our axis correctly, we scaled it as well. Our chart title, and that will signify this. So our chart title is always dependent versus independent, so our dependent variable versus our independent variable. So temperature versus time. And that is the chart title that we were looking for. Okay, cool. So let's go ahead and start answering these questions that they ask us. Okay, so these are analysis questions that we have. Now, I hope you guys followed along. You do have that paper in front of you, so follow along. This is what we're doing here. And then it's going to kind of allow you to analyze this. So, write a complete sentence to describe the relationship between the variables. So the relationship between the variables, we always write a sentence that relates one to the other. Okay, so for example, as time increases, what occurs to temperature? So as time increases, temperature also increases. Okay, so if you can see here, time is increasing as you go from left to right. Now, as you go left to right, what is occurring to these dots? Well, they're also going up, right? So as you go left to right, this dot is higher than this dot. So that means that as time is increasing, temperature is also increasing. Now, let's say we had a line that did something like that. Then it would be a little bit different. So as time is increasing, what's occurring to the temperature if we had a line like that? Well, then temperature would be decreasing, right? So we would have a dot here, and then time comes by. As you move left to right, there's some time that passed, and your temperature was decreasing. So that's one way to kind of analyze how that works. So but in this case, the plotted points that we have, as time goes by, so as time increases, temperature also increases. Okay, good. So let's go ahead and move to number 3. So number 3, the way we do number 3 is finding the slope of the line. So you're going to kind of have to look back at this chart. Now we want to take the slope of the whole data set. The best way to do that, you know what, I'm going to change colors. I'm going to make this red. So let's go ahead and make this red and find the slope. So when we find the slope, we want to take it of the whole data set. So the best way to do it is to take, now if we recall, now I'll just write the equation here. Now if we recall, the equation to find slope is y2 minus y1 all over x2 minus x1. Okay, and that gives us m, which is the slope. Okay, now in this case, we just have to pick y2 and y1. So for the whole data set, this is our y2, this is our y1. Here would be our x2. Now we have these two need to be correlating to one another. So x2, y2, and then in this case, this would be our x1. Okay, so if we go back to number 3, let's just go ahead and plug in those numbers. So I chose y2 to be 75 minus y1, which is 25, all over x2, which is 100, minus x1, which is 0. Okay, now if we do some calculations, what does this equal? So 75 minus 25 is 50, all over 100. Okay, so our slope in this case, if we reduce it, is 1 over 2, 4.5. Good. That is our slope that we got so far. Alright. Good. So, let's move on to number 4. Number 4 asks, what does this slope represent? So you just calculated, right? We just calculated the slope of a line. And we got that to be 1 over 2 or 0.5. So what does that tell us? Okay, so what exactly does that tell us? What it tells us is this. So slope is rise over run, or y over x, right? So you had y2 minus y1 all over x2. So that's our y variables over our x variables. So what that means is that it is our dependent variable over our independent variable. Now if we have a slope of 0.5, it tells us that for, now let me go ahead and rewrite this in this manner. So our dependent variable is temperature. Okay. Our independent variable is time. What this tells us is, what this 0.5 tells us is that for every minute that passes, temperature will increase by 0.5 degrees. Okay, so let me repeat that. For every minute that passes, our temperature will increase 0.5 degrees. Okay, now if we had it reduced to 1/2, same thing. For every 2 minutes that pass, 1 degree Celsius, or 1 degree Fahrenheit, okay, or sorry, it was Celsius, 1 degree Celsius will increase. So that's how we read this. So let's go ahead and write that out in a complete sentence. So again, for every independent variable, for every one independent variable, 0.5 dependent variable is going to increase because 0.5 was our slope. So in this case, we have this. My pen just went away. Okay, so for every minute that passes, the temperature will increase by 0.5 degrees Celsius. Okay, so that's what this slope represents. It doesn't just represent a number, it actually tells us something within this graph. So let's look at our graph to see if that makes sense. Okay, so right here, about 1 minute passes, half a degree goes up. Okay, so let's see if the boxes correlate. So 2 and 1. Okay, that makes about sense. So now our slope tells us this story here. For every minute that will pass, the temperature will increase by 0.5 degrees Celsius. Good. Okay, let's move on to the next question. So what is the y-intercept? The y-intercept, if we look at our graph, the y-intercept is the moment at which the line touches the y-axis. Okay, so at what moment does this line, our line of best fit, touch the y-axis? Now there's 2 ways you can do this. One, you can look at your line of best fit and see where it touched the y-axis. Now this will be an approximation. So you can say pretty much at 25 degrees. So at 25 degrees, the line touches the y-axis. That could be one way you do it, so 25 degrees. The other way you do it is if you grab two. Okay, now grabbing 2 points, you would have to go back to the data set. Alright, so now if we look at the y equals mx plus b line, you would have to, we already found m. Okay, now we're trying to find b. So y is anything in our dependent variable, x is anything in our independent variable. So any number within our dependent variable, any number within our independent variable. And then we just plug those numbers in. Now m we found to be this number right there. Okay, that's our slope. That is m. So for y and x, we just go back up to our data set here, and we pick one number. Okay, so I'm going to pick 10 and 30. So y is going to be 30, x is going to be 10. And then I'm going to plug those numbers in and see what I get for my y-intercept. Okay, so x I said was going to be 10, y was going to be 30, my intercept is 0.5, and then I am solving for b. Okay, so 0.5 times 10 is 5. Alright, so then I have 30 is equal to 5 plus b. Subtract by 5, subtract by 5, and then I get 25 is equal to b. So as you can see, that's very same exact answer. Okay, so you could do it either way. Both ways are correct. Alright, so now that we found b, we have b and we have m. We can now write an equation for this line. Okay, now first let's write the equation for this line. Let's write it out in the y equals mx plus b form. Then we can plug in the correct variables. Okay, so y equals mx plus b, so y is equal to m, which is 0.5, x plus the b that we just found, 25. That is your y equals mx plus b line. Now, to plug in the correct variables, all you need to do is substitute whatever your y and whatever your x are. So in this case, our y is indicative of our dependent variable. So what is our dependent variable? Our dependent variable is temperature. So instead of saying y, what we say is temperature is equal to 0.5 times our independent variable, and our independent variable, if you recall, was time plus 25. This is our correct line with variables. Awesome. Okay, so last question that it asks. So, number 7. What will the temperature be after 85 minutes have passed? Right, use the equation you wrote. Okay, so now we have this equation. We're going to use it to solve this problem. Okay, so we have temperature is equal to 0.5 times time plus 25. Okay, so here we know our minutes, we don't know our temperature, so all we have to do is plug in this number into time, and we can solve for temperature. So temperature is equal to 0.5 times 85 plus 25. 0.5 times 85 is 42.5 plus 25, 42.5 plus 25 is equal to 67.5. So our temperature after 85 degrees, or 85 minutes, so at 85 minutes, our temperature would be 67.5 degrees Celsius. Okay, now that's all we need to know regarding graphing. Now we did 3 things, okay, so we did multiple things. We found our slope. When we first learned how to graph it, we found the slope from the graph, we drew a line of best fit. From there, we figured out what the slope represents. We found the y-intercept. Once we found the y-intercept, we were able to create a y equals mx plus b line and plug in the correct variables. Now that you have the correct variables, you can use that to solve your problem. Okay, now I want you guys to try the back of your worksheet. Okay, now that you know and we went over how to do this, I want you guys to try the back of your worksheets. Okay, if you have any questions, I'll be coming around. Please ask me for any help. All right, thank you.